Hello everyone, welcome back again to the channel and to another Arch Linux installation. Yesterday the ISO for October 2020 of Arch Linux was released, and in this video we are going to make the base install of Arch Linux on a UEFI system and on a MBR system. So without further ado, let's get going. So here we go, let's install Arch Linux with the October 2020 ISO. I downloaded already the ISO and I put it up already the machine from there, and this is the standard login screen. Now I know this is a little bit small for you guys to see on the display, so let's increase the font size here, and to do this I'm going to use the Terminus font, which is actually already present in the live installer. So to increase the font size I will type in now set font, and then I'm going to define the font, which is ter for Terminus -132 and then N, and then we can hit enter. And there you go, we have now the bigger font available. So let's begin installing Arch Linux. This is a UEFI system and I have another machine here with an MBR system on, to which I will switch to when it's needed, for example, to format the disk or installing grub, as those are the only two differences between these two installations. So the first thing I'm going to do is to change my keyboard layout, because the Arch ISO, as you probably already know, comes with a US keyboard layout. So because I have a Swiss keyboard, I will have to change this. To find out your locale for the keyboard, you can type in localctl list-keymaps, and then we're going to use the pipe symbol here to pipe the result of this command into the grep function. The grep function is going to help us basically filter these results. And we need to give a parameter to the grep function. So in my case, because I have a Swiss keyboard, the connotation is CH. You replace this accordingly, and then we can hit enter. And you can see these are the keyboards available with my layout. So I'm going to select the first one to load in memory, and I'll type in load keys, and then the string itself, which is de_ch-latin1. And I can hit enter. And there you go, the keyboard is now installed. So we can clean up the terminal and proceed to the next step, which is checking our internet connection. So let's type in IP space A and hit enter. And you can see in this machine, I have one interface, which is ENP1S0. So it's an internet connection. And as you can see already, I have an IP there, which is ending with 162. So that means internet in my case is working out of the box. But if you have Wi-Fi, you will need to use the iwctl command. Now, because I don't have a Wi-Fi card in here, I cannot show you that directly, but I can show you the command. So let me clean up the terminal, and you can type in iwctl and hit enter. So when we typed in before IP space A, you should have seen the name of your Wi-Fi adapter there. In case that you don't remember it, you can type in device list and hit enter. And if there is one, you will see that under the name. So this is how you can find out the name of your Wi-Fi adapter in case you forgot it. The next step is to scan for networks. So you can type in station, and then you'll define the name of your Wi-Fi adapter. In most cases, it's going to be WLAN 0. So I'm going to use this also in this case, just as an example. But of course, replace this with the name of your Wi-Fi adapter. So I'm going to type in here WLAN 0 and then scan. Once you hit enter, your Wi-Fi adapter will scan for networks. The next step would be to type in station and then the name of the Wi-Fi adapter. So in my example, WLAN 0, and then get networks to see the list of networks available. Then once you see that yours is in there, you can then type in station and then the device name, so WLAN 0 in my example, connect, and then the name of your network. Whatever the network name is, you'll just type it in and hit enter, and you will be asked for the password. Once you enter the password, you will be connected to the internet as well. Then once you have done that, you can type in here exit, and you will be back into the root Arch ISO. So let's clean up the terminal. So now that we have an IP, we need to synchronize the network time protocol by typing in time date ctl and then set-ntp true and hit enter. This is an important step to do because we need to make sure that the time is synchronized with the internet when we download packages. Now, the next step is to make sure that we have the fastest mirror list available to us so that we can download packages as quickly as possible. And to do this, we're going to use reflector, which is already present in the Arch ISO. So let's use it by typing in reflector-c for country. You'll define your country here. In my case, it's going to be Switzerland. If you have a country with two words like United States, for example, you need to put them between single quotes and then -a for the age of the servers. In my case, I'm going to look for servers which have been updated since 12 hours. So I'm going to type in 12 and then --sort to sort the servers by speed, so rate, and then --save to save the information under /etc/pacmand/mirrorlist. And hit enter. It's going to take a second to do that. There you go. And now let's synchronize our servers by typing in pacman-syy and hit enter. And now we are ready to continue. So let's clean up the terminal and type in lsblk and hit enter. So you can see there we have only one disk in this machine, which is called VDA, and we need to partition this disk in order to install Arch Linux. Now, this is a UEFI system, so I'm going to create here two partitions which are mandatory. One is the EFI partition, the second one is the root partition. Those two are mandatory. You can optionally also create a home partition if you wish to do so. So because it's a UEFI system here, I need to actually partition the disk with the GPT label. And in order to do this, I'm going to use a utility called gdisk. So because it's already present in the ISO, I'm going to type in now gdisk and then /dev for device, and the device name is VDA, and hit enter. And you can see now we created new GPT entries in memory. So we can go ahead and create our first partition. So let's type in n for new and hit enter. The partition default is number 1, which is fine, so we can hit enter. It's going to be also fine for the first sector, so we can hit enter here. And the last sector defines basically the size of the partition, so we need to tell how big is this partition going to be. So I'm going to do it 200 megabytes. So I'm going to type in here plus 200, capital M, and hit enter. Now this has to be a EFI partition, but right now, as you can see, the current type is Linux file system. So we need to find the code basically for the EFI partition. If you don't know the code, you can type in capital L here and hit enter, and you can search now for the EFI partition. So I can type in here EFI and hit enter, and you can see EFI 00 is the code for the EFI system partition. So I'm going to type in here now EF00 for the code and hit enter. And now the partition type has been changed to EFI system partition. Now let's create the second partition by typing in n for new and hit enter. We'll accept the default number 2. First sector is also fine, so we just hit enter. And I'm going to accept also the default for the last sector because it's the remainder of the disk. So I'm just going to hit enter here. And this is a Linux file system, so the code is already there, and I accept the default by hitting enter. And now we can write the changes to the disk, which is the last step, by typing in W and hit enter. I want to proceed, so let's type in Y and hit enter. And then partitions have been written to the disk. So let's clean up the terminal. Now let's type in lsblk again. And you can see we have our two partitions there. VDA1, our EFI partition, and VDA2, our root partition. So let's begin formatting these partitions, and let's begin with VDA1, which is our EFI partition. So to do this, we can type in mkfs for make file system. And the EFI partition has to have a FAT file system type. So let's type in FAT. And then we need to specify the FAT32 file system type. So let's type in -F32. And then the device name. So /dev/VDA1 and hit enter. Let's repeat the process for the root partition. So let's type in mkfs. And then dot, we need to define the file system type we want to create on this installation. I'm going to use here very simply ext4 because it's one of the most mature file systems. So I'm going to type in here ext4 and then the device name, which is /dev/VDA2 and hit enter. And there you go, the partitions have been formatted. So let's clean up the terminal. And let's mount our partitions as well. So what we need to mount first is the root partition. So to do this, we can type in mount. Then we specify the device name /dev/VDA2. And the mount point is /mount, which is our installation directory. And we can then hit enter. Next, we need to mount our EFI partition. But for that, we need to create the directory for it first. So let's create the directory by typing in mkdir-p. I'm using the -p option here because I want to create multiple directories. If you just want to create one, you can just use the mkdir command. So then I'll type in /mount, which is already existing. And the directories I want to create are boot and EFI. So this is because I want to mount actually the EFI partition in this specific directory. But you can also mount the UEFI partition onto the boot directory if you prefer to do that. Then I can hit enter. And now I can mount VDA1 in here by typing in mount /dev /VDA1 and then /mount /boot /EFI. And then I can hit enter. Now, if we type in lsblk again, you can see our mount points here. We have VDA1 on the EFI partition and VDA2, it's mounted into the mount directory. So everything looks good. And now let me switch over to the MBR system to show you how we can partition an MBR system there. So this is the MBR system, and let me type in lsblk. You can see I have again the same disk here. This is 80 gigabytes and the disk name is VDA. So let's go ahead and format this disk for an MBR system. So an MBR system requires a DOS disk label. There are some instances where you can actually also have a GPT label on an MBR system, but then we have different requirements also for the partitioning. So in this case, I'm just going to use the standard DOS disk label. So to partition the disk in an MBR system, I'm going to use fdisk, which is also already available in the Arch ISO. So to do this, I'm going to type in fdisk and then /dev /VDA and hit enter. Now you can see it created a new DOS disk label with a disk identifier. And what I'm going to do here, I'm going to create a swap partition and a root partition, which is mandatory. The swap partition is here recommended. I didn't do it in the UEFI system because there I'm going to create actually a swap file later. But in this MBR system, I'm going to create a swap partition. And that is because typically older systems like legacy systems do have actually less RAM than UEFI systems. Of course, this is not always the case. But if I take a PC from 8 years ago, it's most likely to have less RAM than a newer machine today. And for that reason, a swap partition is going to be helpful because it's going to basically help the computer when the RAM is basically full. So for this reason, it's very useful to have this swap partition here. So to create the swap partition, I'm going to type in n for new and hit enter. And because it's a DOS disk label here, it's asking us whether it's a primary partition or an extended partition. This is a primary partition. And as you can see, we can create 4 of those maximum. So we can accept the default because it's primary already selected. Partition number 1 as a default is fine. So we can hit enter here. The first sector is also fine. We can accept the default. And the last sector basically defines the size of the swap partition. So this MBR system has 1 gigabyte of RAM only. So the rule of thumb is to create double the RAM. So I'm going to create basically a 2 gigabyte swap partition. So to do this, I'm going to type in +2 capital G and hit enter. Now the type is Linux, and that's not actually correct because I want this to be actually a swap file type. So let's type in T for type and hit enter. And if you don't know the code, again, we can type in capital L and hit enter. And you can see already here on the bottom where it says aliases, we have swap is equal to 82. So let's put in here 82 and hit enter. And you can see now change the type of partition from Linux to Linux swap, which is what we want. Next, let's create our root partition. So let's type in n for new and hit enter. And again, it's a primary partition, so let's accept the defaults here. Partition number 2 is fine, so we can accept the defaults. First sector is also fine. And the last sector is going to be also fine. You can also eventually create an own partition if you want to do that. But in my case, I'm just going to create one root partition because it's mandatory. And I can hit enter here. And this is a Linux file system type, so that's fine to me. And we can type in W to write these changes to the disk. And the changes has been written to the disk. So let's clean up the terminal and type in lsblk. Again, we have here our swap partition, 2 gigabytes, and our root partition. So let's format these partitions. Well, we don't need actually to format the swap partition, but we need to make the swap and activate it. So let's do this by typing in mkswap and then /dev /VDA1 and hit enter. And now let's activate the swap by typing in swap on /dev /VDA1 and hit enter. Now let's format our root partition by typing in mkfs.ext4. Again, we make a file system with an ext4 file system type, and then the device name, so /dev /VDA2 and hit enter. And there you go. So let's clean up the terminal, lsblk, and now we need to mount these partitions. Now the swap partition doesn't need any mount point, so we can leave that, but we need to mount, of course, our root partition. So to do this, we can type in mount /dev /VDA2, and then the mount point is /mount, and hit enter. If we type in again lsbk, you can see we have now our mount point there. So we are ready now to install basically the base packages. Now let me switch over to the EFI system because the procedure is going to be exactly the same. So we are back again here in the UEFI system. As you can see, we have VDI1, which is an EFI partition. So let's go ahead and install the packages we need. Again, this procedure is going to be now the same for both systems, UEFI and legacy. So let's type in packstrap and then /mount. We are basically installing the base packages into the mount directory. And the base packages are base. Then we need to install also the Linux kernel, which is Linux. You can install also another kernel if you want to do that. You can install Linux-LTS if you wish, or Linux-Zen. These are different kind of kernels. But in my case, I want to install the latest kernel, so I'm going to install the Linux kernel. And then I want to install also the Linux-firmware package, which is going to provide some extra firmware for the system. I need to install also an editor, which we'll need later. In my case, I'm going to install Vim. And if you have an Intel processor, you can install also Intel-Ucode. Or if you have an AMD processor, you can install AMD-Ucode. So once you are done typing, you can just hit enter here. Now, this is going to take a moment to download and install the packages, so I'll be back when it's done. So there you go, the packages were installed. So let's clean up the terminal. And the next step is to generate the file system table. Again, this step is the same for both UEFI systems and legacy systems. So to generate the file system table, for those of you who know, the file system table is the file where all the mount points are stored. And when the machine boots up, it will read this file to mount the devices. So to do this, we can type in gen for generate fstab and then -U. Now the capital U switch here means we are using the UUIDs of the partitions to generate the file system table. This is important because the UUID is actually unique to each device. It's always a good idea to use UUIDs instead of disk names because if you one day maybe plug in another disk in your system, the disk names might change, whereas the UUID of the devices will never change. So it's always advisable to use the UUID. And then /mount. And we are going to append actually the information that we have right now by typing in twice the major than symbol to /mount /etc /fstab, which is the fstab in our installation. And then we can hit enter. There you go. Now, if we type in cat /mount /etc /fstab and hit enter, you can see we have here our two mount points because this is a EFI system. So we have here our EFI partition and also our root partition. So everything looks good and we can clean up the terminal. In the legacy system, you will see the swap partition and your root partition mounted in the fstab file. Now that we have the file system table set, we can proceed and enter the installation itself by typing in arch-root/mount. This is valid for both systems, so we can hit enter. And you can see the login prompt change. So that means we are now in the installation itself and not anymore in the ISO installer. So let's clean up the terminal. Now this next step is specifically only for UEFI systems and not for MBR. So you can skip this if you are on a legacy system. And this is actually to create the swap file. Now, the reason why I create a swap file here compared to the swap partition is because this UEFI machine has plenty of RAM and I just need to create a swap file. It's a little bit more flexible because you can always delete it and recreate it with a different size if you need to do that. Performance-wise is not as performing as a partition, but because I have plenty of RAM, probably the swap file is never going to be touched anyway. So to create the swap file, we need to type in dd and then if equal /dev/0 of equal /swap file. So we are creating basically an empty swap file. Now we need to define the size for it and then bs for block size. And in this case, I want to define 1 megabyte size for each block and then count. So basically the count says how many blocks you want to have the swap file for. So in my case, I'm going to type in here 1024. So it's going to be 1 gigabyte swap file. And then status equal progress to see the status when we run the command. And then we can hit enter. There you go. So the swap file is created. Now we need to change the permissions on it so that it can be read on. So to do this, we can type in chmod for changing permissions 600. which is defining the reading permissions, and then /swap file, and hit enter. We need to change these permissions because now we need to make the swap. And to make the swap, we need to have those permissions. Otherwise, we cannot activate it. So let's type in now mkswap and then /swap file and hit enter. And now let's activate the swap by typing in swap on /swap file and hit enter. And now we have our swap file. Now we need to still put it in the fstab file so that it's available when the machine boots. So let's type in vim /etc/fstab and hit enter. And let's go down here to the empty space in Vim and create a new line with these parameters. /swap file, it's the name of the file. A tab, and then we need to define the mount point, which is none. The swap file doesn't have any mount point. Then a tab, and the file system type is swap. A tab again, we need to define the options, which for the swap file are defaults. A tab again, and then the dump is 0. And the file system check is also 0. We don't need to check the swap file at boot. Then we can save the file and exit Vim and clean up the terminal. Now that we have the swap file, we can go ahead and work on our localization stuff. Now from here, the procedure is the same again for UEFI systems and legacy systems. So we need to basically first define the time zone of the system. To do this, we can type in time, date, ctl, and then list-time zones. And again, I'm going to use the pipe symbol to pipe the result of this command into the grep function, which is a filter. And we can filter basically by city. So the city of my time zone here is Zurich. And then I can hit enter. And you can see I get my time zone there. So I need to put this into the system by typing in ln-sf. So we are basically creating here a symbolic link, and then /usr, and then share, and then zone info / we define our time zone, so Europe /Zurich in my case, and we are going to link this to /etc/local time and hit enter. There you go, we have now the time zone set. Now because that is set, we need to synchronize the hardware clock and the system clock. So let's do this by typing in hwclock --sys2hc and hit enter. There you go. So let's clean up the terminal now and work on our locale.gen file. So the locale.gen file basically contains the locales that we need to select for the system. So to edit this file, we can type in vim /etc/locale.gen and hit enter. So let's look for the locale we want to have. In my case, it's English US. So I'm scrolling down here with Control F in Vim, and I see English US is down here. And I need to have the UTF-8 version. So I'm just going to delete here the hashtag and then save the file and exit Vim. And I can generate now the locales by typing in locale-gen and hit enter. And we are done with the locales. Now we need to create also the locale.conf file. So to do this, we can type in vim /etc/locale.conf and hit enter. And let's enter the string there by typing in lang equal en_us.utf-8. And then we can save the file and exit Vim. Now, if you chose another keyboard layout at the beginning of the video, you'll need to put this also into the vconsole.conf file. So to do this, we can type in vim /etc/vconsole.conf and hit enter. Enter here key map equal your keyboard layout. So de_ch-latin1 in my case. And then we can save the file and exit Vim. So this is done. We can proceed by working on the host name, so the name of the machine. So let's type in vim /etc/hostname and hit enter. I'm going to give the name to this machine and I'm going to call it Arch 1020 for the month and the year of this ISO. And then I can save the file and exit Vim. Now I need to work also on the hosts file. So let's type in vim /etc/hosts and hit enter. And let's go down here and create a new line in Vim. And let's type in 127.0.0.1 and then localhost and then the IPv6::1 tab localhost again. And then the last line 127.0.1.1 a tab and then our host name. So in my case is arch 1020.local domain and then a tab again, and again the hostname, so arch1020. And then we can save this file and exit Vim. So it's time to give a password to the root user. So let's type in passwd and hit enter. Enter the new password and retype it. And the password has been updated successfully. Now we need to install some extra packages for the bootloader, our networking tools, and other things. So let's do that by typing in pacman-s. The first package I want to install is grub, the grub bootloader. Now, because this is a UEFI system, I need to install also the EFI boot manager. If you are on a legacy system, you can skip this package because you will not need it. But if you are on a UEFI system, you need to have this. So let's type in EFI boot MGR. Then I want to install also network manager and also network manager applet. It's going to be useful eventually later for a desktop environment. I will install also dialog. And I'm going to install also two packages for working with fat file systems. One is mtools and the other one is DOS FS tools. Then I'm going to install also the base-devel and Linux-headers packages. These are two development packages, and a word of caution here, if you installed another Linux kernel than the latest Linux kernel, you need to also change the Linux headers here. So if you, for example, install the Linux LTS kernel, you need to install the Linux LTS headers. Otherwise, it will not work. Then I'm going to install also some packages for the Bluetooth adapter. One is Blues, and the other one is Blues-utils. I'm going to install also cups for the printing system, and I'm going to install also ALSA-utils and also Pulse Audio. These two are for the audio system. I'm going to install also Pulse Audio-Bluetooth, and I want to install also Git. It's going to be useful if you want to install some packages from the AUR and also Reflector to have it in our installation. And the last two packages I'm going to install are xdg-utils and xdg-user-dirs for creating user directories. And then we can hit enter. Let's accept the defaults here, and we can proceed with installation by hitting enter. Now again, this is going to take some time to download and install, so I'll be back when it's done. So the packages are installed successfully. So let's clean up the terminal now, and we need to proceed by installing the grub bootloader. Now the procedure here is going to be different if you're using a legacy system. So I'm going to do it first here on this UEFI system, and then I'm going to switch over to the other machine. So to install it on a UEFI system, we can type in grub-install and then --target. We need to specify the target machine equal x86_64-EFI. This is the command for the EFI grub install. And then --EFI-directory. We need to specify where is our EFI partition, which is, if you remember, /boot/EFI. This is the mount point where we mounted our EFI partition. And then --bootloader-id equal grub. And then we can hit enter. It's going to take a second to do this. There you go. And now we can generate the configuration file for grub by typing in grub-mkconfig-o. So the output of the configuration file is going to go under /boot and then grub, and the file is grub.cfg. And then we can hit enter. And this is done for the UEFI system. Now let me switch over to the MBR system, and I'll show you how you can install grub there. So here I'm on the legacy system, and I have already installed grub, of course, because we installed it before. Again, as I said, you don't need to install in a legacy system the EFI boot manager. This is only useful if you have a UEFI system. So to install grub here on a legacy system, we can type in grub-install. And then again, --target, we need to define here the target machine. Now, this is a little bit confusing. Some people don't understand why we need to type in here i386-PC. It's not that this is a 32-bit machine. It's just that for grub, the i386-PC means it's a legacy system. So once we have done this, we can type in the disk name because we don't have any EFI partition or any partition here. So we can type in /dev/VDA. Now, this is going to work because we created just a swap partition and a root partition, and that's going to work most of the time. Now, I mentioned when we formatted the disk for the legacy system that there is actually a way how we can use a GPT label with a legacy system. For that, however, to work, we need to create also a boot partition and make that partition bootable. Otherwise, you'll not be able to install grub. But this, as I said before, it's only in the case you want to have a GPT label on a legacy system. For a DOS label on a legacy system, this command is just going to be enough. So we can hit enter here. And there you go, installation is finished. We can also here create the configuration file for grub by typing in grub-mkconfig-o, and then the output again goes under /boot/grub, and then grub.cfg, and hit enter. And there you go, this is done for the MBR legacy system. So let me switch back to the UEFI system because from here on the procedure is going to be the same for both systems. So now that we installed grub, we can proceed by activating some of the services we need for our system. That means, for example, the network manager, which is taking care of our internet connection. We need to make sure that this is enabled so that when the machine boots the next time, we have already an IP available, or we are able to configure the Wi-Fi. So to do this, we can type in systemctl enable and then network manager with capital N and capital M, and then we can hit enter. We do the same for the Bluetooth service, so we can pull up the last command here with the up arrow and replace network manager with Bluetooth and hit enter. And we do the same again for the CUPS printing system. So let's pull up the last command and replace Bluetooth with org.cups.cupsd and hit enter. There you go. So we can clean up the terminal and create also a user for the system. Now let's create a new user by typing in user add -m capital G and then wheel and then the username. So in my case, my name, and hit enter. So what we did here, we basically created a user called Hermano, my name, and we gave him a home directory, that's the M option, and the capital G option is basically giving also a supplementary group to the user, which is the wheel group. The wheel group has to do with the sudo privileges, which we will configure in a second. Now, before we do this, we need to give the user a password, otherwise he will not be able to log in. So to do this, we can type in passwd and then the username and hit enter. Enter the new password and retype it. And there you go. Now, to be able to give sudo privileges to this user, we need to type in editor =vim and then sudo and hit enter. We'll go down here until we find the wheel group we just talked about, and we need to find the first one, which has the line saying all = all, and delete the hashtag here so that the wheel group is available. That means every member of the wheel group will have sudo privileges. So we can then save the file and exit Vim. And this is basically done for the installation. So what we need to do now, we need to type in exit and hit enter. Unmount all the partitions by typing umount-a. And then we can reboot the machine by typing in here reboot and hit enter. So it's going to take a moment here to reboot. And you can see here we have Arch Linux, so grub is installed correctly. So let's boot up the machine. And there you go, we have our login there. So we can log in, for example, now as a user and the password. And there you go, we are logged in now in our installation. So from here on, basically, you can proceed by installing the desktop environment or the window manager of your choice. For that, I have already videos on the channel that you can check. And there you will install the graphic drivers, you will install also the XOR group and all the packages you need for whatever desktop environment or window manager you want to install. So this is going to do it for the base installation of Arch Linux with the October 2020 ISO. And if you have any questions about this, let me know in the comments below and I will be more than happy to answer you. So there you go, this is the installation with the October 2020 ISO of Arch Linux. For this installation there were no changes, but we have actually in this ISO a new kernel, which is the 5.8.12 kernel. So if you have any questions about the video, let me know in the comments below, guys. If you have any suggestion or if you have any trouble installing Arch Linux, let me know in the comments below and I will be more than happy to answer them as soon as I can. I hope you liked this video, guys. If you did, please hit the thumbs up and subs to the channel if you haven't already. Subs always helps us out. And if you want to support the channel, you can do so by visiting our Patreon website, or you can donate via PayPal to our website as well. Thank you so much for watching the video, guys, and I'll see you very soon in the next one.